All right, hello and welcome to the Off by One Security Stream. Today I've got some very special guests here. We've got Corey Ball, who is the author of Hacking APIs. He's a senior manager of pen test consulting at Moss Adams and creator of APISec University that he will tell us about today. He has an amazing free course there on API penetration testing where you're going to learn a ton more about that, and we're going to see some really cool demonstration of that a bit today. Our volunteer of the day who will be going and interacting with the target environment is Chris Dale. He's a principal SANS instructor. He has his own company called River Security, doing all kinds of awesome things like offensive security and attack surface management and cyber consulting. So really great guest today. And I'm excited about this because this is an area where I'm not incredibly strong at. So I plan on learning a ton of information myself. So guys, if you want to give yourself a little bit more of an introduction, that'd be awesome. Corey first.
Sure. So yeah, by day I'm a senior manager of pen test consulting over at Moss Adams. So I help pen test clients, help build new clients for Moss Adams, and help manage the team of awesome testers we have over there. When I'm not doing that, I'm chief hacking officer over at APISec University. So we just released my course back in November, was the first 1.0 release of that. And it's completely free. All the tools are free. And then if you complete it, there's a certificate of completion that goes along with that. And then we just released an API fundamentals course, which gets into the very high level basic security for APIs.
Cool.
Awesome.
And I'm Chris Dale, principal SANS instructor as Sim said, and basically founder of River Security. Been doing pen testing for a long time now, and originally a developer, and been doing lots and lots of web application hacking. So, and that also entails API hacking. So I can't wait to be the bunny to go through all the challenges and hoops of this show.
Awesome. Thanks. And so I guess start out with a couple questions here. I think the format we're going to have in this session is just going to talk a little bit, and then I believe Corey will give us a few slides, introductory slides on what we're going to be looking at, and then we will move straight into demonstration. I guess as I started saying initially, I'm not strong in this area. So I know like at SANS, for example, we've got a cloud pen test course, we've got a bunch of traditional pen test courses, and APIs specifically, they've been hot lately. They should always be hot, of course, but for example, I remember just seeing a couple weeks ago with ChatGPT, like 80 different unknown or unavailable or advertised APIs were available. Someone found them, told the world about them, and then they went and hid them. So I know from my understanding, a lot of times they are not advertised. So the whole security by obscurity thing, a lot of times you've got situations where there might be older APIs that have changed over time, and you can look for things that have been added and removed, which is a very traditional way of testing web environments anyway. But I guess, Corey, can you tell me a little bit of information about like what specifically is API pen testing? What are we trying to accomplish there?
Sure. So if we're talking about API-focused pen testing, of course, that's a portion of good web application testing. So APIs, in 2019, there's a stat out there that APIs represented over 83% of all web traffic. And so that when we're talking about good web app pen testing, of course, a big portion of that is going to be APIs. So APIs have their own way of being used. They're non-graphical. They are a common form of communication between applications, and they often lead directly to the most valuable resources that criminals are after, which is private data. And so they are a path beyond the classic MITRE kill chain where you have to gain access from the external network, get past the firewall, get onto an internal device, pivot around, find the databases, and find a way to exfiltrate it. So instead of that, if you're able to find a vulnerable API, you could just do that all from interfacing with it from outside the network to begin with. And we see plenty of breaches that are related to this. If a criminal is able to use an endpoint unauthenticated or without authorization, it accesses sensitive information. They're just able to gather that and either sell it or do something else with it. So APIs do have their own OWASP project. So there's the OWASP API Security Top 10. And those are 10 risks that are unique to APIs. So some that you've already mentioned, improper inventory management or improper assets management. APIs deal with versioning and how you're able to access data. So you'll see an API that's on v3, and maybe version 1 of that has vulnerabilities that haven't been patched or they're no longer supported. And so you could find weaknesses by attacking old versions of it. But with APIs, the most common vulnerability that's out there is authorization-related vulnerabilities. So this is accessing the API as an authorized user and then attempting to either create, read, update, or delete resources of another user. And if you're able to, then you're able to gather that sensitive data, you're able to make changes, perform privilege escalation, essentially wreak havoc over the APIs.
Interesting. So like, I know some APIs are well documented. Some are documented if you're a need to know basis, but still that information gets out there. For things that are undocumented, how do you go about discovering them?
Yeah, so the business purpose behind APIs is to enable developers to connect with another application that's out there. So the documentation side of the API is really to help out another developer on a public or partner API. So that just tells them, hey, here's the API, here's the functionality, and here's how you use it. And so if it's publicly documented, there isn't much of an issue there if there are security controls in place to control things like authentication, authorization, and to make sure that users are only able to use the API in ways that they're meant to.
And so for things like, would there be a different set a lot of times for, say, mobile apps versus just a regular desktop user?
For APIs, there's a lot of crossover between mobile APIs and web APIs. So you're going to be interacting with those over HTTP requests. So as long as you know how to form well-formed API requests using HTTP, likely using something like Burp Suite or Postman in order to interact with those, then you should be able to make well-formed requests, whether it's to the mobile endpoints or to the web endpoints.
Interesting. So I know, like, I was looking at Corellium. I don't know if you've heard of that, but Corellium is a vendor who won a lawsuit that Apple had against them because they were virtualizing the Apple iOS and allowing people, of course, to do anything from jailbroken kind of attacks against the underlying kernel to looking at and being able to access the application to application access and such. So I was just that's where my head was going. I was wondering from that perspective if there's like a whole new set of doors that open up because you have that ability to interact with the applications on the mobile device. But it sounds like you're saying it's pretty much, if it's reachable by the mobile apps, it's going to be reachable by a command line Linux system.
Yeah, you may be able to discover that, and there may be different requirements that are in place or controls that are in place between web apps and the mobile apps. But yeah, in the end, you should be able to access them in a very similar way. You may be able to discover them better from the mobile side, but then you can move into using Postman or Burp Suite and making those requests that way.
Okay, so we got this question I just put up on the screen for you. Thoughts there?
Yeah, I mean, those are the HTTP methods that are out there. So you can work with APIs using a variety of these. With REST endpoints, there aren't concrete controls that everyone adheres to. So you could see a variety of request methods used in different APIs. But typically, with if we're thinking of CRUD, create, read, update, delete, delete's going to go with delete. Update is typically going to be a post, but you can see put used for that as well. You could see get with query parameters used. Yeah, so it just depends on the API. But of course, if you have something in documentation, you can always test beyond that. You can do directory brute force attacks to attempt to find endpoints that are no longer supported and are not a part of the documentation. And you can also test for those other methods to see if those are enabled when they shouldn't be.
Yeah, awesome. Cool. So I'll go ahead and share out your slides here because I know people obviously want to get to the meat. So if you want to go ahead and take us through some stuff here, and then we'll jump into the live demos.
Sure. I'm going to skip around a little bit through this slide deck. Yeah, if anyone's interested in AppySec University, you could just go to appysecu.com or go through all the work of pulling out your camera and scanning the QR code. If you do want to follow along with this, we're not going to use all of these tools on the presentation today, but essentially you're going to want to have Postman, Burp Suite, these other tools you could use for reverse engineering an API and building your own Swagger documentation. But today we're primarily going to focus on Burp Suite. Okay, just to dive in a little bit further into what APIs are. APIs are a technology that facilitate a common method for application-to-application communication. So I'd like to use the restaurant metaphor. If you're completely unfamiliar with APIs, what do they do? If you think of APIs like a restaurant, you go into the restaurant and you want to order some food. You don't need to know all the ingredients and the methodology for making the dish, but you can go and sit down and then you can work with or just talk to the server or waitress or something like that. And they really function as the API. They know how to communicate with you. They know how to communicate with the chef. And so you pull out your API documentation or your menu, and you can choose exactly what you're looking for. And then you can communicate that, and they'll take it to the back of house where they say, they ordered number 1. The chef knows exactly what that is. They prepare it. They serve it back to you. So just like that, you don't have to know or specialize in something like map creation. You can depend on the specialization of a company like Google. And then you can interact with Google Maps and use the documentation to request back information or functionality from that. A few different types of APIs that are out there. There's public, which are going to be internet exposed, easy to find, well documented if they're meant to be consumed by others. Partner APIs, these could be more challenging on the documentation side. The documentation may not be public. It may just be shared over email with a partner or over some other private means. And then a private API, these are going to be used privately within an organization. And so these may not be documented at all. And there could be very limited knowledge on the dev team of how to interact with these. Yeah, just a few other facts about APIs besides the 83% of all web traffic is API related as of 2019. 2022, there's a report 46 million Postman collections. So a Postman collection, if you're not familiar with that, it's just a collection of API requests. And so you'll have all the endpoints, all the requests that can be formed. This can function just like API documentation, if not even more usable, because the requests are already built out. And you end up replacing a few variables to interact with the API and get the information that you're looking for. On top of that, as of today, there's around 3 million API-related repos on GitHub. And so why attack APIs? I think APIs are a path of least resistance. Insecure APIs are a quick path to the goods, which is private data. And so, yeah, this is just going over what I've talked about with the kill chain. There's a lot of steps here. A lot of security controls could be in place in between these different areas. And if an API is insecure, it's just going to bypass all of that and get you straight to the data. So APIs work over HTTP. So these are just applications. It doesn't matter what the application is built on, as long as it can make HTTP requests. So then you have your request methods that we've already discussed, and you're getting back response codes. So you need to have a well-formed request. Often the data interchange is going to be JSON. Sometimes you see XML, but there's a common method for sending and retrieving data. And you need to have an understanding of, when a server responds a certain way, what does that mean? And what would be an anomalous response? A good thing to have a grasp on when you're testing APIs is the most common vulnerabilities that affect them. This is from the OWASP 2019 list, or actually, no, this is actually a compiled version that I put together with top 8 vulnerabilities here. There is the OWASP API security project that was published, their top 10 list in 2019. That's going through a revision and release this year. So the 2023 version is actually already out there. And so here we see, again, at the top of this list, we're going to have authorization vulnerabilities. So broken object level authorization and broken function level authorization. With each of these, you're looking at, can I access and retrieve the resources of other users? And then can I create, read, update, or delete those resources through the functionality? And so with BAFLA, which is on the functionality side, am I able to use admin endpoints or admin requests in order to perform actions? Am I able to control the resources of other users or groups? Authentication problems, those are prevalent. We'll see during the workshop that actually we may not get to that, but essentially APIs and authentication, if there aren't things like rate limiting in place, then you could just continuously make requests to the API. And if there aren't security controls to lock out an account, then the API is going to enable you to brute force that account, or to brute force maybe a multi-factor code that goes along with a password reset, something like that. Another finding that's specific to APIs is excessive data exposure. And so this is when you make a request to an API and it sends back way more information than you had originally requested. So you may request information about your user account and you're getting back information about the admin, or you're getting back information about other users. And we'll see this vulnerability exploited later on. Improper assets management, we've already touched on. Mass assignment, so this is the ability to perform unauthorized actions to property level items within objects. And so if we're creating a new account and you're registering over an API, you'll see some properties like username, email address, password. But if you're able to add on other properties that are valid, so there's some way that an organization manages and creates admin accounts. And so if there's something like is admin equals true, then you add that on. And if there aren't any restrictions in place, then you could hypothetically make yourself an admin from there. Security misconfiguration. So out of all of these items, automated scanners are pretty bad at testing APIs. And this is the one that they'll often find. So anything from CORS issues, verbose headers, using HTTP when it should be using HTTPS, any sort of misconfigured header, that's all going to fall under this bucket. And out of all the API findings, scanners really only pick up and find this one. There aren't even definitions in a lot of the more popular web app tools to find this, which is a big issue with API security because that often leaves organizations with a false sense of security when they're getting back false negative results from these scanners that they've depended on for a while. Insecure design and business logic flaw. So, just like any application, it could be configured with bad logic that enables attacks, or maybe, is more or less vulnerable by design is how I think of this one. Final one I've touched on a little bit with authentication, which is lack of rate limiting. So if you can just continuously make requests to an API, you can do lots of things with APIs. So authenticate, request data, post data, upload files, a lot of that stuff. And so if you're able to just upload file after file with little to no limitations on the size of it, then you can imagine there's a cost associated with that and some risks. So I think at this point we can hop into the workshop and get our hands on a vulnerable application and begin testing. Cool. So I'll make this whole slide deck available if you want to dive deeper into the reconnaissance aspects So what we're going to do is hop on over to crappy.appysec.ai.
All right. Let me know, Chris, when you got that URL, and I'll put your desktop up.
All right, up and running.
All right. There we go.
Great. And then you're proxying all of this to Burp Suite, correct?
Right now, using Foxy Proxy to Burp Suite to send everything to Burp.
Very cool. So what I always recommend when interacting with an API-driven application is to just use the thing as it was intended. And so if you want to just hop on, through the browser. Did you already go through the account registration?
I'm not.
Okay. Yep. Go ahead, sign up. It does have like a password policy in place, and you'll need to remember the email.
Got a dumb password.
Yeah.
Ooh.
Oh, you know what? I think there's a phone number. Yeah.
Does it really want me to leak my OPSEC details here? I'll just do this. Like OPSEC wise, will be good, right?
Yep. Cool. And so here, you can start going through your profile at the top right, perform a couple of actions. There's the change password. We don't need to, if you want to, you totally can. And then there's the tabs up at the top for the dashboard, shop, and community. And we'll just want to go through a few of these. Go ahead and just buy any of these items. Good stuff, yeah.
Some good prices.
Got myself a new gaming chair. Nice.
That's a child seat, I think.
I won't say it's a child seat. Of course.
Cool. And let's go. You can push OK here. Oh, yeah. And go back over to the dashboard when you have a chance. And here we can see this is the primary functionality of Crappy. So it's really functioning as maybe like a car repair web app that allows you to check in your vehicle, purchase additional parts, talk with the community, and you have your own profile that goes along with it. And so here we have to access the MailHog portal. Standard way from a tester to find this would be a quick Nmap scan of crappy.appysec.ai. We could run that really quick, or yeah, let's do that.
Default.
Maybe do an all port, or like, let's expand on the ports a bit.
Sure. We'll do an aggressive scan, scanning the top 10,000 most common ports.
I think that should do it.
I did put in the QR code while we wait. I did put the QR code into CyberChef. Parse it as a QR code. It takes us to a bit.ly link, which transfers us to Yippee. All right. So it's also doing an Nmap scripting engine right now. So it's actually performing a couple of scripts on top of the ports. But it looks like we got a 2280, 1025. Were we looking for something else?
Yeah, we're looking for something up in the 8,000 range.
All right. So we'll do 8,000 to 9,000.
That should do the trick.
And we'll do a sim scan, speed it up a little bit. 8025.
Perfect. So that's going to be MailHog. So we can go check that out.
HTTP. Looks like it is.
Yep. And then if you just hit that, the button back on Crappy, I'm not sure if you hit it. That was probably you 4 minutes ago, but we can double check it.
Here?
Yeah, this click here button.
Click here button.
On the dashboard.
Click here to send information again. Gotcha.
Cool. Go ahead and hit OK and add vehicle. Now we can go back to the mail Hog instance. This is going to give us our VIN for our vehicle, as well as the 4-digit code.
I see other people signing up with my no reply, by the way. we got listeners registering accounts right now, so we're going to see if anybody's going to be trolling us. What do you want me to do?
That top email, you can select that one.
This one here.
Yeah. And then go ahead and copy over the VIN and PIN code.
Like this.
Yep.
Verify?
Yep.
I can't wait to check out the sitemap in Burp Suite in a second.
Yeah, let's do that right after this.
All right, cool.
Cool. And so now your Lamborghini is registered.
Heck
and then
yeah.
Down below you have your Google map that your vehicle's over at Area 51 right now in Nevada.
Makes sense. Makes sense.
Perfect. So let's swap over to Burp Suite and see what we got in the sitemap.
All right, cool. So it looks like we got workshop, API, static stuff. It's an identity API, something random stuff, and a community API, version 2.
You have any idea, Chris, why your mouse cursor's there's like 3 or 4 of them blinking all over the place at all times? I'm not sure why it's doing that.
I have no idea. I see that in StreamYard as well, but it's not on my screen though.
I was afraid you're all seeing that. I'm just gonna remove and add again. Hold on 1 second.
I could try to, I got this yellow cursor.
Try it now. Oh well, must be some. We'll just have to tolerate it. No worries.
Sure. I'll open up the mouse settings and meanwhile to see if we can remove the pointer to the default one. But yeah. All right, cool. We got a sitemap, Corey.
Yeah, let's check out the community post while we're here. So let's, if you want to send this over to, actually, let's check out the recent one. And then if you want to send it over to Repeater, and then we can see the whole interaction. So a couple things to note right away. Over on the left-hand side, we can see that this is an API request, Crappy. We can see that for authorization, after we've provided our username and password, we're provided with this bearer token. And if you can tell, if you want to highlight it, you can tell this is a JWT down in the authorization under bearer. And then JWTs are base 64 encoded, so you could always see what data is being passed in the header and payload.
I feel like you've used these tools before, Chris.
Yep. Yeah.
Yeah, it's good to see Cyber Chef out in the wild. I'm not the only one. Yeah. Yep. Good stuff. And so we can hop back over to Burp Suite. And the path of this request is the community post recent. So if you're going into the forum and you're talking with other people, this is the request that's populating that web page. And the interesting thing here, let's pull that page back up in the browser. And so here you see the forum. You see username, you see the date it was posted, and then you see the content of their post. But if we switch back to Burp Suite, we'll see a lot more information is being provided with us. So with this request. So this is the excessive data exposure that I was describing earlier. So in the API request, as a response for this, we would expect to only see those same items that are populating the web page. But instead, we're getting everyone the idea of the individual posts. We're seeing the content, but beyond that, we're seeing the email address for other users. We're seeing the vehicle ID for other users and profile pic URL. I mean, so some of that would be understandable, but that vehicle ID as well as the email address probably not too necessary. And
how common is the excessive data exposure, would you say, Corey?
Getting less common. So it's good to see there is some effort and push that's decreasing this. Used to see it all over the place. And essentially, I mean, if we want to use the term laziness, one developer is saying, here's all of the data, you parse out what you need on the other end. And so one thing we're seeing with between REST and GraphQL, for example, GraphQL enables the query to request exactly what you're looking for. So you see excessive data exposure happening a lot less with GraphQL, unless too much is queried, of course. But I don't know why they would. But with REST, you could just say, here's the full data object, and that's giving you everything that's associated with it for this page. So you still do see it. On its own, you could find very interesting information disclosure. Here, that vehicle ID, that's not going to be something you could just brute force and find on your own. Of course, you could create a user A account, a user B account, and get it through that method. But here, that's a very unique ID that's being shared for every user that comments here, along with their email address, which could make other attacks easier as well.
I would like to add to that as well. I mean, considering like developers are basically, we've got two different kinds of developers: one front-end developer, one back-end developer. And the back-end developer writes the API, and sometimes there's a disconnect. Who's responsible for the business logic of things? Like who controls like how you should interact with the data? And some API developers, they just say screw it, and they expose everything to the clients, which could be a mobile app, it could be a web app, but that kind of leads into these kind of problems, right?
100%. So next thing we're going to do, since it does look like vehicle ID is a sensitive piece of information, I wonder if we could do a search for that property and see if we could find it elsewhere in Burp.
Sure. So we got some posts mentioning the vehicle ID. We can make it scroll automatically to the target. So here we have a request to a post. And
so with these, let's actually look for the key. Let's look for vehicle ID as a single word and see if that's used elsewhere.
Right now, it looks like it's in comments, and it's in posts, and also in the recent in the parts of the community. Maybe we haven't explored the full API yet, but yeah.
Yeah, let's go through. Let's check out other requests in the API and see if we can spot. Maybe it's not named vehicle ID, but we could think through other places where vehicle ID might be used. And so that registration page is the first one that comes to mind because that's the main one that's associated with this. So let's check this page out.
I'm sure my car has an API. It's got to have, right?
Definitely.
So cool. We did something. Should we search again?
So instead of searching, let's just go through the API requests. Actually, maybe. Okay, yeah, let's just go through them. That's going to be on the dashboard. Let's see if the dashboard has a request for it.
So let's see, dashboard. We're up here. Do I need to?
No, I think there's a request right below.
There it is. Yeah.
Let's see what that one. So yeah, this doesn't look like an API request. It's just a request for the dashboard page. Let's go back into the dashboard one more time. And let's see what else. So there's the contact mechanic button. Let's go down. And there's also this refresh location. Okay, let's check that one out in Burp. Okay, so in the URL path.
Sorry?
Oh, I was saying, yeah, in the URL path, we're seeing that request that involves the vehicle ID. So then what we would hope to see is that there are authorization requirements in place for this. And so we could do a couple different things. We could strip all the vehicle IDs that are found in the community requests, or we could just stick this over in repeater, yeah, and replace and see what we could see.
Should we replace it with the other guy's car just to see where they're
exactly.
At? What's saying?
You're saying
so is that following coordinates, it looks like.
Yeah. So this is a broken object level authorization vulnerability. And you could see that where you'd expect authorization restrictions to be in place, that we're able to use another vehicle ID discovered from an excessive data exposure. And then we get the latitude and longitude of any user's vehicle that we have that ID for.
I can feel my fingers start to crawl. Like I wanna get more into this API because this seems vulnerable as like, ooh, it's super juicy, you know?
Yeah, 100%.
Question there from Graham, Corey.
Yeah, Graham, it really depends on the complexity of the issue. Authorization vulnerabilities, pretty standard timing for remediation. Those can be very high risk, high impact findings. And so immediately for most authorization vulnerabilities, within a 30-day window, we're normally retesting 30 to 60 days. The ones that could be more complicated are file upload vulnerabilities that involve APIs, which I don't think there are any for Crappy, but those can be much more complicated because you have everything that's been classically dealt with on the web app side from the browser. So arbitrary file extensions, arbitrary files, and then every method you could think of to bypass those restrictions. And so once that's applied to an API, then, how is that file handled? Where is it stored? Can it be accessed and executed? And so those can definitely be more complicated.
Was it the Tesla or what was that? Whether it was that location leak issue? I remember hearing about that.
I'm not 100% sure, but I think this may be inspired by that.
Yeah.
Also, to add to the answer, like how long does it take for these APIs to be fixed? One of the challenges fixing an API is that typically there's not just one client, right? There could be an arbitrary number of clients, and you impacting or changing your API is going to impact potentially dozens of clients of the API, and the ramifications testing needed to make sure that you don't break something and so on is typically much bigger than in another application, like in a simple web app where the API is sort of like built into the scripts themselves.
Yeah.
Yep. So just to touch on authorization vulnerabilities a little bit more, as a tester, there are really three ingredients that you're looking for when you're trying to find these. And first, you have to find a request like this one that interacts with resources. So this request, and then you have the community post. So both of those are going to hand over and utilize the resource ID. So you need to find a request that involves those resources. Of course, you need to have a vulnerable application that doesn't restrict, this token should only be able to access this vehicle ID. And then everything else should be kicking back a 400. But so you need to have the request, you need to have that resource ID, and then the vulnerable application. And once you have those, that's when you can start looking around the entire scope of what you have to play with in the API. Which if you had a postman collection, then you can start reviewing and doing some of those searches like we did for that property vehicle ID. Where else is that used throughout this entire collection of API requests? And then you can start narrowing down, okay, I have this ID over here. Can I successfully make a request with that over here? And this is finding the latitude and longitude of someone's vehicle. That's you don't want to be disclosing that as an API provider for sure. But this can be even more severe in a fintech API when you're able to, not only request for user B's account balance, but then you can get into broken function level authorization and transfer their account balance back over to yours. So these can have very severe impacts.
Here's a follow-up question from Graham here.
Yeah, so I actually like OneNote. I take a ton of screenshots while I'm testing, and OneNote, you can often successfully search through the images. And so you can have a text search that would find something in your image. And so I just highlight anything that's interesting to me that I will return to. And typically on an API, if I find some resource IDs over in one request, then I'll return back to that and see where else I could use that.
Nice. All right, so what else we got here?
Yeah, do you want to dig in deeper and see what else we can find? What else looks interesting to you from what you've seen so far?
Well, I mean, looking at it, looks like there's a couple of API calls that we could explore for sure. Resending emails, like if you look at input parameters, there seems to be none. So I'm assuming it uses the JWT to kind of like indicate where the email should go to. A vehicle's request does not take in any input parameters, but I mean, where's my little cursor here? What? Oh, there it is. And I get back my own vehicle, it looks like, and my UUID, my Universal Unique Identifier. This is the first time I'm looking at this application, though, so I'm primarily looking for things that have some kind of inputs, some kind of like where I can add something to the script, to the input that is not my JWT, expecting the JWT doesn't have any vulnerabilities that could potentially allow me to say hijack somebody else's sessions or privilege escalate, whatever it might be. So I'm thinking, here's my dummy password, by the way. Yep. Not a disclosure, if you're curious. But yeah, I don't know. I would go about things. So here's a parameter in REST. So it looks like some kind of looks kind of randomized, but it could very well be not random. So I would sequence it with the Burp tool, and I would sequence a bunch of posts and see how random this string actually is, to see if I can bit flip it, to see if I can attack the crypto in any way. Mm-hmm. There might also be things to explore further down this path. There might be more functions, say comment. It might just be one function. There could be other functions available to me. I'm thinking I would also love to discover any non-visible endpoints. So first of all, we haven't really clicked through the entirety of the application, right? I would love to make sure that I've clicked through absolutely every button, every function here to fully build out my sitemap. I would want to make sure that this add coupons here doesn't have vulnerabilities in it. I'm sure there's something. Invalid coupon code. Maybe after I've done content discovery from the visible stuff, and also I would brute force and content discover from a perspective of like there must be more. Like even if I had a Swagger on OpenIPA specification, I would still expect there to be more than what I'm being led to see. But for example, enter coupon code here. say we're done exploring, we would perhaps go in and check out this script here, validate coupon code ASDF did not seem to work, put it into the repeater so I can keep on trying the different types of the functionality to see how it actually behaves. And you see that here it says invalid coupon code, but in the actual API, it actually says the server responded with something bad, like the server crashed in some way. Maybe it tried to look up a database entry that didn't exist or something like that, and it actually fails. Well, it should gracefully fail, saying no coupon exists. It did not actually. So here we would go in and maybe say percentage star. Maybe we'll put in special characters, etc., etc. We'll try to fuzz it potentially, right? Maybe put in some wildcards, etc.
Yeah, I'm going to get in the intruder and run with that. Yeah, I think you'd be onto something.
Definitely see who I'm going to want on my CTF team coming up there.
Yeah.
So first thing I'm thinking is in terms of the coupon code, instead of starting from say a word list containing all kinds of possible attacks, which could be like tens of thousands of requests, I like to start out with bytes, basically just see if there's any special characters that makes the application say behave differently. So I'd go in and I'd go through a simple payload of numbers from 00 to FF, and I'll go hexadecimal because that would be a byte, and then I will prefix it with a percentage. That way, basically, when I start my attack now, I'm essentially adding URL encoded bytes. So %01, %02, etc., etc., etc. Right? It will just go through absolutely everything. And I'm wondering if there's any one of these bytes that are giving me a different kind of reply. And right now, they're all identical. There's nothing special about them. Mm-hmm. So then I would perhaps try to, I could also look at perhaps there's some timing. Here, perhaps some of these has a different timing, like could be something blind, say a character does something special. But these are all pretty much in the same range. And I don't find these to be very interesting at all.
And what if you removed, let's do the same test without the quotations around your attack position.
Beautiful. That's awesome. So instead of forcing this to be a string, we would turn it into an attack against all, like basically the JSON processor behind it, right? Who knows where this input is landing? Maybe it's landing in some kind of post-processing, maybe it lands in a query to a database or whatever. So do the same thing. Let's see what happens. So now we're getting 422s, which is unprocessable entity. Invalid character looking for beginning of value. So that's kind of interesting because that leads me to say I want to URL decode these bytes. So this immediately, my hunch tells me that we're onto something that must be warranted by a proper hypothesis of what makes the application do this, right? So just to satisfy my curiosity, I would go into my attack right now, and I would go in and say payload URL decode these things so that I can see, first of all, if there's anything other. So, for example, here we see numbers actually returning the normal 500s, which is not very normal, but it's still. And we see special characters are generating a lot of noise. I also see some variations in content results here. So if I go to my response here, there's differences. So here we see invalid character in literal null expecting U. And here we see O looking for beginning of value. So this one is kind of like an outlier. It's like now we're starting to engage into, from a zero knowledge point of view, into a possible vulnerability. And I'm saying from a 0 point of knowledge sense, because you shouldn't have to know about SQL injection, command injection, cache poisoning, all these kinds of different types of vulnerabilities. You should be able to explore on your own and figure out that such things exist without the UVA's top 10 and so on. So once this attack is done, it is done. I would go about sort it from a content length perspective. I would disqualify perhaps all of these results with 453. I would disqualify those results because, well, not necessarily disqualified, but I would at least put them in a bucket where I might look at them later. And I'm also looking at the values on the left side here. These are high UTF or ASCII characters, which typically makes the applications misbehave in different ways. And I think it will get more interesting once we go down looking at these characters. And here we have some characters that are looking still okay. 448, just ignoring. And then I want to look for the small ones, like the ones that are giving me something super interesting, like this here, like looking for invalid character. Like this looks like we're breaking apart some kind of string on the server point of view. It's like we're putting ourselves in a string and we're breaking it apart with like a null byte or any other type of special character. So these ones would go into my word list. Now I would continue fuzzing to see if I can repair it with something else. So here you see open parentheses, close parentheses, even the percentage character is coming back here. So I'm thinking I would load up my, there's a comma. Invalid character comma, looking for beginning of value. So I think we're looking at some kind of injection attack here. And that's where I would go about exploring further. So the question is this a CTF? Should I actually go to full distance? And
yeah, go for it. Go for it.
Go for it. There we go.
Yeah, so it definitely help to know the database that's running, but whether that's SQL or NoSQL, and then try some payloads out.
All right. So if it was SQL, I would guess that some of these characters, like double quote, single quote, even backslash, percentage, and the parentheses would have a big impact. The ones that we're seeing have a big impact right now is characters that resemble redjacks, potentially. Also, these are strange as well. So I'm thinking we could perhaps do something along the lines of I'm going to bring it back to the repeater so we can try different things here. Like I'm thinking we could perhaps try some kind of like, say, NoSQL injection potentially. Like say if it not equals 0 potentially, would that be syntaxically sound? I don't believe it is. So I could load this up with another word list containing SQL injection or NoSQL type of injection type of things. So let me do that right now. I'm going to bring this window over here to prevent any OPSEC type of leaks. I'm going to load in a word list that is, well, specifically for this kind of stuff. Fuzzing kind of word lists, NoSQL. So potentially something like this. This is MongoDB, NoSQL type of injections, all kinds of like programming type of things, regex types of like JavaScript comparison type of things. I would also want to load it up with another word list, which is for programming type of things. So these things like 1, 0, you never know, right? All of a sudden, like a 0 or 1, it returns everything. -1, string 1. And I'm going to turn off URL encoding. Null, array, PHP, whatever. Character return, line feeds. So we'll see what happens. So we get an error 500. So these are like how the application behaved before we started injecting new stuff. So interesting enough, like even if we give it an array, it still returns 500. So we could continue on this attack and move inside of the array and start to fuzz it, but maybe there's something easier. So that's my request, and the response comes back invalid character slash, and the slash character would be, it's not our slash character, or perhaps it's this tick here. So it's probably this tick here. So that would allow us to, so I would note that this tick here is getting escaped, but potentially allows us to do something. Invalid character looking for the beginning of key string. I would Google this here. In fact, I'm just going to Google it right now because it's such an interesting error message. It might be something. JSON invalid character, looking for the beginning of object key string. So I just clicked literally, I didn't even look at the results. I clicked the first Stack Overflow link that I saw. And we're seeing this error message. So where's the mysterious invalid here? And correct your JSON syntax. All right, so we're perhaps inside of a JSON type of query. So when accessing, say, a document store like Elastic or MongoDB, we would typically make queries like these. We would have a JavaScript object notation type of syntax where our query would be inside of here. And that query, we could potentially try to impact. So I'm thinking that they're telling us, what is the original functionality here? It's coupon codes, right? So I'm thinking there is some kind of query where we're basically writing our query like this, and there's some kind of like, say, like coupon, and then our value potentially goes in here or something. And because we're allowed to, in fact, it probably looks like this. And we might even be allowed to add a new line, or we could perhaps add our own, say, regex here and perform other types of operations on the database. But it all depends on the target database, the potential ORM behind it, the Object Relationship Manager, that might be impacting the whole ordeal. So considering the error message that we're seeing directly correlates to us having a wobbly JSON, like a non-conforming JSON type of input here, this definitively seems like an issue. And even if I didn't find this issue, if it was a real pen test, if I didn't actually make this into an exploitable condition, I would still ask my customer. I would tell them, hey, this is what we're seeing. Can you help us out with some logs or whatever? And it would definitively go into the report. No matter what, it would go into the report, just like, hey, you're not doing input sanitization here properly, for sure. And looking at these here, invalid character looking for beginning of value. That's potentially super cool. This means an anchor in regex. Looking for beginning of object key string. So that's also super interesting, because now we're basically saying we're allowed to input our own JSON object here. So yeah, I think this is going to be a rabbit hole for me for sure. But I'm thinking we can do this. We can add ourselves in here with attacks, whatever. Like we can add keys, and this is going to make the API behave again, most likely. We could also even do this, and we could probably do something like this. For example, say we would go about try to explore if there's any, like what I would call unlinked parameters. Like maybe there's an ability to do regex here, and we could do, say, regex. Say maybe there's a regex processor that allows us to do any possible character. So now it's saying looking for invalid character. That's a curly bracket, end of curly brackets. So I'm thinking we need to fix this one here. Perhaps not.
So is he on to something, Corey?
Oh yeah, if he goes back to his intruder results, a little more review. I saw it up on the screen for a second.
Did I have it?
Yeah, back in your intruder.
I did have it on my screen in the intruder, did I? Yeah, okay, so let's go back to the attack then. Let's see.
How many? Yeah, with this many payloads, you might want. You did an initial organization by status, and so if we do that again, going at the top, and go ahead and flip the status from 500. One more. There you go. And so you have those three really interesting ones right there. Yeah.
Nice. Yep. That's beautiful for sure. That's beautiful for sure. So basically here we're injecting our payload as a coupon code. We're basically saying screw string. We're actually putting in a JSON object, and we're saying we want to return anything from the database behind it where it doesn't equal null. And that's awesome. And same thing here, greater than empty string, which is everything. It's like a traditional SQL type of injection. One equals one, right? Or one equals one.
Yep, just a truth statement. Yeah, exactly.
So that's interesting for sure. Let's go in here, and we get back to coupon code. Cool. And I would think here we could pivot off into more kind of stuff potentially. We could maybe explore maybe more of the database. Maybe we could even turn it into some kind of command injection potentially. Who knows, right?
Right.
But for sure, it's an interesting finding.
Definitely. Yeah,
good job. Good job, Chris. I wouldn't have found that. I'm not a web guy.
That was really impressive. Yeah.
Good to see that on the fly with a lot of pressure on you.
Well, yeah, pressure is my middle name as a science instructor.
Awesome. Hey, Corey, quick question. I know we don't have time to go into it now. Maybe I can have you back on another time. But like, if you wanted to get started into reverse engineering APIs, like what would you do? How would you get on that path?
Yeah, so I do have those instructions out at AppySec University in the Pentest course. There is a subsection on reverse engineering APIs. Great instructions there. I have a high level in the slides that I'll share. But essentially, there's a cool script that's out there, man-in-the-middle proxy to Swagger. Yep. And so you can use another tool called man-in-the-middle proxy, go through and do a very similar exercise to what we did today. And that's going to create this log file that man-in-the-middle proxy to Swagger can parse out into your own Swagger open API docs. And then you can, gives you a really good starting point if you were to import that into Postman and then begin interacting with it. And yeah, I normally start with Postman because it's very good at testing wide, and APIs can be very wide where you have a lot of different requests and variables that are shared throughout the collection. And so you can test for a single variable across the entire API collection with the collection runner built out in Postman. And then at any point that you want to get back into Burp Suite, you can just proxy it back over.
Nice. Cool. One final question here from admin.
I mean, I review all the responses that I get back, just like we just did, and that was a great exercise to see that done live. And so, just because something's a 500 doesn't mean you should disregard it. Just because something's a 400, really, yeah, you should go through and get an idea of what a standard response is. And we did that with those first 500s that we got back, and we're like, you know, even though we wouldn't expect that 500 to be a standard response. For this application, it was. And so we built that understanding that, hey, this is how it responds to generic bad input. But you want to develop that understanding of how does this application handle data when it's sent? And okay, here's the standard response. So what are the anomalies? And once you can find those, then you can start digging in and asking the right questions of like, okay, so what if I did, inject inside of that array because it was having that response to the array? And it's just those small anomalies that are really like the cookie crumbs that lead you to these awesome findings.
Yeah. Awesome. Well, I think that's a good stopping point, and that was a great session. I definitely learned a lot there, so thank you both very much. Cool. So any closing thoughts before we finish up here?
No, just thanks so much for the invite and having me on.
Yeah, thanks for coming on. It's great. I know Corey and I exchanged books. I gave him a copy of Grey Hat Hacking 6, and he sent me a copy of Hacking APIs. So it's definitely a great.
It's right up there.
Oh, nice. I see. So it's a great read. But with that being said, have a great weekend. Next week, I'm hoping I might have somebody on to cover anti-forensics. It might just be me talking about mitigations. We'll see what happens, but I'll announce that next week. But either way, have a great weekend and Easter if you celebrate that, and we will see you soon. Thanks.
Thanks.
Cheers. Peace out.